Welcome to clickmyproject.com. We will discuss about the energy efficiency optimization for MIMO-OFDM mobile multimedia communication systems with QoS constraints. Next, we will see about the abstract for the MIMO-OFDM communication system. The mobile multimedia communication system is rapid development in the recent years. The main parameter of energy efficiency optimization and the quality of service constraints for MIMO-OFDM communication, the various algorithm to be minimize the energy level for the transmitted signal, but it has some limitation. So we used to propose the energy efficiency optimization, power allocation, and to improve the energy efficiency for the MIMO-OFDM mobile communication system. It is widely recognized that in addition to the quality of service, the energy efficiency is also a key parameter in designing and evaluating mobile multimedia communication systems, which has catalyzed great interest in recent literature. In this paper, an energy efficiency model is first proposed to multiple input, multiple output, orthogonal frequency division multiplexing mobile multimedia communication system with statistical QoS constraints, employing the channel matrix for quality of service constraints. The value of singular value decomposition method, all subchannels are classified by their channel characteristics. Furthermore, the multi-channel joint optimization problem in conventional MIMO-OFDM communication system is transformed into multi-target single-channel optimization problem by grouping all subchannels. Therefore, all closed solution of energy efficiency optimization derived for MIMO-OFDM mobile multimedia communication system. As a consequence, an energy efficiency optimization power allocation algorithm is proposed to improve the energy efficiency of MIMO-OFDM mobile multimedia communication systems. Simulation comparisons validate the proposed EOPO algorithm can be generated to record QoS with high energy efficiency of MIMO-OFDM mobile communication systems. In MIMO-OFDM communication, the various algorithms to be minimize the energy level for the transmitter signal, but it has some limitation. So we used to propose energy efficient optimization power allocation algorithm and to improve the energy efficiency for MIMO-OFDM mobile multimedia communication system. The energy efficient optimization power allocation algorithm used to solve the problem to multi-channel optimize to multi-target in single channel optimization. This method to calculate the channel characteristics using the singular variable decomposition method. Next, we will see the flow diagram for the product. First, we will get the voice input from the user. To put the voice data, to convert the voice data into the input data, then the input data to be convert the binary pattern, then apply to the pre-processing method. The pre-processing method, the input signal is used to voice the voice signal. The voice signal information is converted into input data values. Thus, the data values are converted into binary pattern and given the process. Then the sampled data to be given to the process. Then go to the plot the sampled data signal. Then go to the modulation process. Then the QAM modulation. Then the input data to be encoding the operation, the encoding operation to be interleaving the process. Thus the interleaving process also finished to convert the binary to decimal conversion. Then they apply the QAM modulation, then modulating the input data signal, then go to the OFDM signal generation. The OFDM signal process in the orthogonal frequency division multiplication signal generation. It is the easiest method to signal generate method. Thus the method, every channel to be every separate frequency to be transmitted the OFDM signal. Thus the OFDM signal to be passed the channel efficient matrix. Thus the channel efficient matrix to be allocate the channel allocation in the channel efficient matrix. The padding channel used to estimate the number of channel matrix level. They using the channel matrix method for the Rayleigh padding channel method. The transmitter and receiver level to be finalize the channel efficient matrix. Thus the channel matrices to be modulate the channel level and the OFDM signal. Then plot the real life adding to view the characteristics of channel matrices and also path gain. Thus they go to the SVD method. The SVD method is a singular variable dimension method. Thus the SVD method to be calculate the padding method used to estimate the number of channels matrix level and transmitter and receiver level. Thus the OFDM signal to be modulate the SVD method. Thus the SVD method going to the CSI window. The CSI window is full form. The CSI means channel state information window. The channel state information to be calculate the all characteristics of input channels. Then they calculate the lowest path delay and they measure the quality of service in the transmitting channels. And to calculate the path gain for required lowest path delay and also measure the channel filter delay. The SVD method to be calculate the all channel in the path gains. Thus the path gain method to be calculate the path delay. The lowest delay to be measure the CSI information window. Thus the quality of services to be method followed by this method. The quality of service of energy efficiency optimization process. The main parameter of quality of services is path delay. Path delay to be calculated by the channel state information and to plot the path delay graph. Then they go to the transmitter. The transmitter to be transmit the OFDM signal. Then the receiver to be receives the OFDM signal and to be same reverse process to be also followed by this method. Then the QAM demodulation method to demodulate the signal. Then they go into the received signal. Thus the received signal to be identify the received data. Thus the received data to be calculated by the SNR value and also calculated by the bit error rate value. The signal to noise value and the bit error rate value to plot the various graphs for energy efficiency optimization and energy effective and energy capacity and the effective capacity level also measured. Thus the flow diagram for the whole MIMO-OFDM signal. Thus the process for the modified algorithm in energy efficiency optimization of power allocation method. Finally we will see the output for the product. First we will discuss about the run the first window, then run the first guide window and the to browse the input voice window, then the browse the input voice and open to the read the input voice. Next process the read input voice graph to be displayed by this window. Then go to the convert the input data. The input data to be input voice to converted the input data and the input data voice SNR values to be displayed by this window 25.6779 the SNR value of given input voice. Then go to the next window. The next window to be displayed by the input data value. The input data value to be displayed by this window. The 4110 is the given input voice data and the limitation of 0 to 100 limitation values to be displayed by the graph. Then the MIMO-OFDM signal for the input voice signal. Then go to the next window. Next window to be first given to the length of the channel matrix values. The values to be given to the 4. Then the rising fading channels to be displayed by the given 4 channel matrices and real life fading graph for the given channel matrix values and correlation density function for given channel matrix values. Then go to the next process. Next process will be channel matrix path gain to be displayed by this table. Then the path delay to be displayed by the every path gains. The minimum delay to be calculated by this window. The minimum delay is 0.75786. Go to the next process. The cascading CSI information table to be displayed by this window. The number of transistor values to be given to the process. Number of transistor 4 at the same number of receiver to be 4. The CSI table to be displayed by the path information for the path delay and path gain and channel filter delay for the both transmitter and receiver. Then the quality of service graph. The quality of service graph based on the delay process, path delay process. Then the quality density function for transmitter and receiver table. The number of transistor 2 for this graph. Number of transmitter is equal to 4 for this graph. Then go to the received signal. The given input signal same as to the received signal data. Then go to the next process. The next process is power analysis graph. Power analysis process. The various power analysis methods to be displayed by this graph. The SNR values given to signal to noise ratio values and the quality of service constraints values to be displayed. Then the effective capacity values based on the average power constraints and the effective capacity values. Then go to the energy efficiency based on the average power constraint and the energy efficiency values. Then go to the effective energy. Effective energy is based on the average power constraint and the effective energy values to be displayed. Finally, we will see all the output for the product.